Imagine carefully budgeting $10 million to build and train this state-of-the-art enterprise AI system.
Right.
You've got the boardroom buy-in, the initial trial is a complete success, and the deployment goes live. Everyone is celebrating.
Lopping the champagne.
Exactly. And then maybe a few months later, you look at your cloud computing dashboard and realize your annual keep it running bill is going to be $40 million every single year.
Yeah, it is. It's the kind of financial reality check that is currently sending shockwaves through executive suites globally right now.
I can imagine.
I mean, the paradigm has really shifted from the excitement of building AI to the harsh reality of actually operating it.
Which is exactly why we are here today, because if you are a European business leader or a CTO or a developer evaluating AI adoption, that $40 million surprise is the exact scenario we are actively trying to avoid.
Right. Nobody wants that meeting with the CFO.
Seriously. So we're taking a deep dive into AetherLink's 2026 Infrastructure and ROI Guide.
It's a fascinating document.
It really is. And our mission for this deep dive is to unpack how organizations are moving past those fun, isolated pilot programs and actually deploying highly profitable, mission-critical AI.
And understanding the mechanics of this shift is just incredibly urgent.
Yeah.
We have officially hit what the industry has labeled the 2026 inflection point.
Right.
Gartner's latest projections indicate that by 2028, 33% of all enterprise software is going to feature what they call agentic AI.
33%.
Yeah, a full third. That represents a fundamental overhaul of how software functions.
Yeah.
I mean, the conversation in the C-suite is no longer about whether to deploy AI.
That ship has sailed.
Exactly.
Yeah.
The new directive is how to deploy it profitably at scale and, crucially, how to do it while navigating some incredibly strict emerging regulations.
Okay, well, let's establish a baseline here first, because before we can diagnose the costs or dissect those regulations, we really have to understand the capability jump that is driving this enterprise obsession.
Yeah, that makes sense.
You use the term agentic AI, and I think we need to draw a hard line between the chatbots we've been tolerating for the last few years and a true agentic system.
Oh, they belong to two entirely different computing paradigms.
Right.
A traditional chatbot is fundamentally constrained by pattern matching. You type in a query, the software scans its training data, calculates the most probable sequence of words to respond with, and outputs an answer.
So it's basically just guessing the next word.
It is purely reactionary. In a standard customer service deployment, those older systems resolve perhaps 40% of queries independently before failing and transferring you to a human operator.
Which is marginally helpful for deflecting basic FAQs, but it definitely doesn't transform a business.
Not at all.
I actually like to frame the difference this way. Think of a traditional fadbot as a front desk receptionist who is only authorized to hand you a printed brochure.
That's a good way to look at it.
Right. You ask a complicated question, they just point to a paragraph in the pre-approved pamphlet. But an agentic system is an empowered floor manager.
A huge difference.
Yeah, because if you come in with a complicated problem, that floor manager can walk to the back warehouse, check the physical inventory, negotiate a return policy exception based on your loyalty status, and issue a refund directly to your credit card.
All without ever asking the boss for permission.
Exactly.
And that analogy really captures the mechanical difference perfectly. An agentic AI operates with autonomy and memory.
Right.
It exhibits goal-oriented behavior. So instead of just generating text, an agentic system can actually execute multi-step workflows across external systems.
So it's doing things, not just saying things.
Exactly. It can authenticate via APIs, pull live data from your CRM, execute a transaction within predefined boundaries, and then evaluate the outcome to adjust its behavior for the next interaction.
Wow.
Because of that structural autonomy, an agentic system in a customer service role isn't hitting a 40% resolution rate. It's clearing 70 to 80% of issues without human intervention.
That is massive. And when you embed that level of autonomy into a third of all enterprise software, the adoption metrics just skyrocket.
Oh, absolutely.
Like McKinsey's data shows 65% of enterprises committing anywhere from $5 to $50 million annually to these agents through 2026.
The tool to rush.
Which brings us crashing right back into that jarring financial reality check from our intro. The Stanford AI Index 2024 report highlighted a staggering statistic.
The inference spending.
Yes, inference spending, meaning the ongoing cost to actually run these models day to day, is projected to surpass $150 billion by 2026.
Yeah, it's the inference iceberg. Everyone fixates on the initial phase, the millions of dollars required to train a large language model or license a foundational one.
Right, the shiny new toy phase.
Exactly. But the ongoing, often hidden financial drain is the inference infrastructure. Having a model answer millions of queries, process workflows around the clock, and run complex reasoning tasks, it costs multiples of the initial training investment.
So that's how we get to the $40 million surprise.
Yeah. A mid-market enterprise might spend $2 to $10 million on initial setup, but their year-one inference costs routinely balloon to $15 to $40 million.
Okay, I want to dig into the physics of this. Why is it so incredibly expensive just to keep the lights on?
The bottleneck is hardware. Specifically, there is a severe constraint in GPU and TPU capacity.
Those are the specialized microchips, right?
Yes, the ones required to perform the complex mathematical operations these models rely on. Every enterprise attempting to deploy AI is suddenly competing directly against massive research labs and cloud hyperscalers for access to the exact same finite supply of semiconductors.
So it's like trying to run a commercial airline.
How do you mean?
Well, buying the 747 is a huge, intimidating upfront capital expense, right?
Yeah.
But your actual existential threat is the daily fluctuating price of jet fuel.
Yes.
In 2026, GPU compute is the jet fuel. If you don't engineer a more aerodynamic plane, you will just bleed capital on every single flight.
That is the exact dynamic at play. To survive, enterprises must adopt incredibly rigorous optimization strategies. AetherLink outlines this in their AI lead architecture methodology.
Okay, let's get into that.
You cannot just deploy a trillion-parameter model to handle every mundane task. You have to implement technical interventions like model quantization.
Okay, let's pop the hood on quantization. We hear that term thrown around a lot, but mechanically, how does shrinking a model actually save a company millions of dollars?
Well, think about how a neural network operates. It is essentially a vast web of parameters, or weights.
Okay.
Traditionally, these weights are stored as highly precise decimal numbers, 32-bit floating point numbers.
Which take up a lot of space.
Exactly. Moving those long decimals in and out of the GPU's memory takes a tremendous amount of time and energy. Memory bandwidth is actually the primary bottleneck, not just raw processing speed.
So quantization is basically changing the math itself.
Yes, it is converting those long decimals into much shorter, less precise numbers like 8-bit integers.
Okay, give me an analogy here.
It's very similar to taking a giant, uncompressed, raw image file from a digital camera and converting it to a JPEG.
Oh, I see.
You lose a tiny fraction of the color depth, but the file size shrinks by 80%.
Right, and it loads way faster on a website.
Exactly. When you apply that to an AI model, the memory footprint drops drastically. The model loads faster, requires significantly less compute power, and slashes your inference costs by 40%.
Wow.
All while maintaining 95% or more of its original operational accuracy.
That makes total sense. You are optimizing the data transfer itself. But the guide also points to architectural changes, specifically hybrid routing systems. I imagine that means you aren't sending every single user request through the most expensive, highly capable model you own.
Right, a hybrid architecture relies on the specialized traffic cop system.
A traffic cop.
Yeah. When a user prompt comes in, the routing system evaluates the complexity of the request. So if a customer is just asking, what are your business hours, the router sends that prompt to a very small, highly quantized model that costs fractions of a cent to run.
Makes sense. Don't use the genius for basic stuff.
Exactly.
No.
But if a user asks, can you cross-reference my contract's indemnity clause with French labor law?
That's a bit heavier.
Much heavier. The router identifies the high complexity and forwards it to your premium trillion-parameter reasoning engine. Organizations that master this routing technique capture the lion's share of AI productivity gains because they simply stop overpaying for simple tasks.
Okay, so we've solved the back-end cost bottleneck with quantization and smart routing. But honestly, none of that computational efficiency matters if the system can't actually communicate effectively with your employees or your customers.
So true.
Which brings us to a really fascinating shift detailed in the AetherLink guide regarding the user interface. Text-only chatbots are officially labeled as legacy technology.
Yeah, they are out.
Voice is the standard for 2026.
The evolution from text to voice has been remarkably swift. But the distinction here is really vital.
How so?
We are not talking about the old dictation pipeline where the system translates your speech to text, feeds that text to a language model, generates a text reply, and then uses a robotic voice to read it back.
Oh, because that old method loses all the nuance. Sarcasm, urgency, hesitation, all of that is stripped away when you convert speech to plain text.
Precisely the issue. The 2026 standard is built on direct audio input.
Okay, so it listens directly.
Yes. The models process the acoustic features natively. They analyze the sound wave itself, bypassing transcription entirely.
That is wild.
Because of this, the agent detects tone, pacing, and emotional state in real time. It recognizes when a caller's voice tightens with frustration, or when a pause indicates confusion.
Which changes everything.
It allows the AI to dynamically adjust its conversational style, perhaps slowing down or instantly escalating the interaction to a human supervisor.
And what's the result of that?
Customer service teams deploying native voice are documenting average handle times dropping by 25 to 40%.
Okay, I have to play devil's advocate here on behalf of everyone listening.
Go for it.
When you say AI voice agent, my immediate thought goes to the infinitely frustrating automated phone trees we all universally despise.
Thanks, Steve.
You know, press 1 if you are angry, press 2 to yell at a machine. How is an advanced AI voice agent not just a glossier, more expensive version of that nightmare?
It is the single most common skepticism CTOs express.
I bet.
The differentiator between a maddening automated phone tree and a genuinely helpful AI colleague boils down to one foundational concept: context.
Context.
A traditional phone tree operates in an absolute vacuum.
Yeah.
It has zero context about who you are, what you're trying to achieve, or the history of your problem.
It treats every single caller like an amnesiac.
Exactly. But an agentic AI designed to manage multi-step business processes, like coordinating an employee's onboarding across HR, IT, and payroll, it requires a sophisticated contextual framework. And the AetherLink guide categorizes this into 4 distinct layers.
Let's break those layers down. I assume the first layer is just basic memory.
Yes, historical context. The AI accesses an immediate record of what occurred previously with this specific user, the status of their ongoing contracts, or where they left off in a workflow.
So the user never has to repeat themselves.
Never. The second layer is organizational context. This is where the AI internalizes the company's operational boundaries. It understands internal policies, risk tolerances, and compliance frameworks.
So going back to our floor manager analogy, organizational context is the manager knowing exactly how deep of a discount they can offer a VIP customer without getting fired by the regional director.
That is a perfect illustration.
Awesome. And the third layer?
The third layer is situational context. The AI evaluates the current environment to determine if this is a routine interaction or an anomaly requiring special handling. Finally, we have relational context. The system understands how the specific task it is executing impacts broader business objectives or other interconnected workflows across different departments.
So when an AI operates with all 4 layers, historical, organizational, situational, and relational, it stops feeling like an obstacle you are trying to bypass.
Exactly.
It behaves like a highly competent colleague who has already read the briefing document before joining the meeting.
And the return on investment for building that specific infrastructure is substantial. Organizations dedicating resources to construct these context engines, integrating knowledge graphs and mapping existing databases, they report 35 to 50% higher workflow automation success rates.
Wow.
They evolve from merely automating isolated tasks to achieving true process intelligence.
Which sounds phenomenal from a productivity standpoint, and there's always a but. If we take a step back, giving an AI the autonomy to execute complex workflows, analyze human emotions, and make financial decisions based on organizational risk tolerances.
Yeah, here it comes.
That introduces immense compliance vulnerabilities, which leads us directly to the reality every European enterprise must face right now.
The EU AI Act.
The EU AI Act.
It is arguably the most consequential regulatory framework of the decade, and its implications for agentic AI are immediate and severe.
Because under the EU AI Act, since these agentic systems exercise autonomous decision-making, they are legally classified as high-risk AI.
Yes, high risk.
And that designation carries heavy obligations. You cannot simply deploy a model and monitor the results later.
No, not anymore.
Companies are legally bound to implement human-in-the-loop review protocols for decisions exceeding certain risk thresholds. You must establish transparency mechanisms so users understand the logic behind a decision.
Right.
Furthermore, you need unbreakable cryptographic audit trails for every autonomous action.
And the penalties are no joke.
The penalty for failing to comply. Up to 6% of your global annual revenue or 30 million euros, whichever is higher.
Those penalties are structured to represent existential threats to non-compliant organizations.
Definitely. However, AetherLink's analysis presents a really compelling strategy here. They advise companies to completely reframe their perspective on this regulation.
Wait, I think I see where this is going. If I am building an AI that automatically approves or denies vendor invoices, the EU Act requires me to be able to explain the exact logic behind why the AI denied a specific invoice, down to the granular data points.
You have to map the exact decision pathway, yes.
So you couldn't use a gigantic, unexplainable black box model even if you wanted to. You are legally forced to use smaller, highly explainable, tightly constrained architectures.
You just nailed the hidden genius of the regulation.
Wow.
Compliance actually enforces cost efficiency.
That is a brilliant aha moment, because building for compliance forces you to utilize the exact same quantization and hybrid routing strategies we discussed earlier for saving money.
Exactly. It forces organizations to build inherently more reliable, trustworthy, and explainable systems right from day one.
That's incredible. Think about it. If your engineering team must construct a system capable of auditing its own decision-making process to satisfy a European regulator, they have simultaneously built a system that is incredibly easy to debug, optimize, and scale.
It's a win-win.
It really is. European enterprises embracing this framework actually gain a significant global advantage. Their underlying AI infrastructure is fundamentally more robust than systems hastily assembled in less regulated environments.
That reframing changes the entire conversation around ROI. Speaking of which, let's talk about the timeline for seeing a return on these investments.
Okay, let's get into the numbers.
The guide is quite adamant that organizations must follow a disciplined roadmap, particularly when it comes to the initial architecture.
The financial case is incredibly strong, provided leadership resists the urge to rush into production.
All right, don't rush.
AetherLink details a 4-phase adoption roadmap. Phase 1 is discovery and architecture, typically requiring 3 to 6 months. This phase is absolutely critical. This is the period where you define the specific use cases, establish your data governance, and design that compliant, context-rich architecture we just unpacked.
And I noticed a stark warning in the source material. Organizations attempting to skip or compress Phase 1 end up facing implementation costs that are 3 to 4 times higher later on.
Because if you fail to build the context library and the explainability protocols up front, your deployment phase turns into a nightmare of constantly patching hallucinations and reverse engineering compliance.
You're just putting out fires.
Exactly. You will pay for the architecture. Eventually, doing it later is just exponentially more expensive.
Pay now or pay later.
Right. Following a disciplined architecture phase, you move into pilot implementation, then production deployment, and finally, continuous optimization.
Okay, so if an enterprise follows that structured roadmap, what does the actual financial timeline look like? Like, when do the efficiency gains outweigh the infrastructure costs?
For a typical mid-market enterprise, year 1 is focused on hitting break-even, or perhaps a 1.2x ROI.
So year 1 is just stabilizing.
Yeah, you are absorbing the costs of the initial deployment, integrating the context layers, and refining the hybrid routing.
But year 2 is where the operational leverage kicks in.
By year 2, as the infrastructure efficiency takes hold and the models are heavily quantized, organizations typically see a 2.0 to 2.5x ROI.
Nice.
Moving into year 3 in mature operations, that figure scales to a 3.5 to 5.0x ROI.
And looking at the breakdown of where that value originates, it isn't just about replacing human labor.
Not at all.
The guide indicates that 40 to 50% of the ROI stems from pure cost reduction processing tasks faster, utilizing less compute via quantization, and minimizing human error.
Right.
But a surprisingly large portion, 30 to 40%, comes from revenue enhancement.
Because these agents possess deep historical and relational context, they excel at accelerating complex sales cycles, delivering highly personalized product recommendations, and drastically improving customer retention rates.
That makes total sense.
And the remaining 10 to 20% of the ROI is derived from risk mitigation.
Specifically avoiding those devastating EU AI Act penalties we talked about.
Exactly, and ensuring policies are applied consistently across the board.
It basically transforms AI from a basic cost-cutting mechanism into a primary growth engine, assuming the underlying architecture is sound.
That is the big caveat.
Right. Which brings us to our final takeaways. Synthesizing all of this, the inference iceberg, the mechanics of quantization, the shift to voice, and the regulatory landscape. My primary takeaway is really a complete shift in perspective regarding competitive advantage.
Tell me more.
In 2026, dominance isn't about licensing the most massive, computationally greedy AI model on the market. It is strictly an engineering game.
Absolutely.
The winners will be the organizations that deploy the most efficient systems. Mastering inference costs through smart routing and deep context is the actual secret to enterprise success. An incredibly smart model is basically useless if it bankrupts you to run it.
I share that perspective entirely. My major takeaway is the philosophical shift from basic task automation to genuine process intelligence.
Oh, I like that. Process intelligence.
Yeah, the realization that an AI can now deeply comprehend the relational and organizational context of a business, that it can understand the why behind a corporate policy,
Right.
and how an isolated task impacts broader company objectives. It completely redefines the boundaries of software.
It really does.
It transitions from being a passive tool to an active participant in the workflow.
The empowered floor manager.
Exactly.
Well, if you want to dive deeper into these strategies, explore the 2026 Infrastructure and ROI Guide and find more AI insights. Visit AetherLink.ai.
And as you evaluate your own AI roadmaps, consider this final thought.
Lay it on us.
We know these agentic systems are continuously learning from outcomes. They are constantly updating their understanding of your organizational context and executing autonomous decisions on your behalf thousands of times a day.
Right.
At what threshold does the AI stop merely reflecting your company's existing corporate culture and begin actively shaping it?